Thank you. Wow, what a morning. It's great to be in North Carolina where we have great people, great universities, and folks that really want to get things done. Much of our advantage is driven by new technologies, and our next speaker will show us the new possibilities, the emerging connectedness of designers, builders, and consumers. Chris Anderson is here to share how individuals are harnessing the virtual power of the internet to make real products, ushering in a new industrial revolution. Chris is a highly sought after speaker on the business effects of new technology, and his newest book, Makers: The Next Industrial Revolution, focuses on how communities of makers and the web have liberated innovators from the claws of big manufacturers. He is the founder of both DieDrones, the open source community with 12,000 people and 3 factories worldwide, as well as 3D Robotics, a robotic manufacturing company that began as a hobby with his children. Now, that's a heck of a company. Now, Chris has an interesting background. Graduated from high school, didn't do so great in college. He's done great since then. I think what got him off to a great start was playing bass in a punk rock band. If you know punk rock music, I'm not sure there's a lot for a bass player to do, but I'm sure Chris did it well. As editor-in-chief of Wired, Chris led the magazine to a number of national magazine awards, winning the top prize for excellence in 2005, 2007, and 2009. Chris has stepped down from his role at Wired magazine after a successful 12-year run to become the CEO of 3D Robotics. Please join me in welcoming to the stage Chris Anderson.
Thank you. It is a real pleasure to be here, and thank you for an opportunity to not only be in North Carolina, but also to talk to my people. I'm now a manufacturer, like many of you. I quit my job as the editor of Wired in December to take over our manufacturing company. We're not based in North Carolina yet, but who knows, by the end of the day. But what I'd like to talk to you about is really my own journey of discovering that manufacturing is incredibly cool. And my new book largely chronicles not only, this sort of rediscovery of manufacturing, but also what's different about manufacturing now and why the digital revolution has come to manufacturing to potentially transform the biggest industry in the world. Before I start, I wanted to introduce a little show and tell that we're going to be doing here. Here's Adam Rogers, who's going to be my 3D printer assistant. This is a 3D printer Replicator 2, and while I'm talking, it's going to be making a Darth Vader head out of plastic, or conjuring it from the ether and instantiating it in plastic right here in front of us. We're going to make a very small one because it needs to be done before I'm done. But just imagine that there could be a full-size Darth Vader head in as well. Thank you, Adam. All right, well, let me just dive in and talk a little bit about what's changing and why this moment is perhaps the most exciting time in manufacturing since the original Industrial Revolution. My own story starts here. This is my grandfather, Fred Hauser. He was a Swiss immigrant to Los Angeles in the 1930s, was working in Hollywood when at MGM was a mechanical business. And by day, he worked on the talkies, and by night, he dreamed of new things. He was an inventor as well. And this is him at his drafting table, and this is what he invented, the automatic sprinkler system. So if you have an automatic sprinkler system, you have my grandfather to thank. By the way, this is exactly what a Swiss engineer in Los Angeles would invent. Swiss engineers are all sort of watchmakers of various sort. An automatic sprinkler system is just a sprinkler system with a watch on top of it. It's a timer. Those little clock timers you can get today with little pins you put in for the various hours. That's exactly what he invented. This is sort of a family heirloom. that is both the best and the worst of 20th century invention. What's great about it is that it's his patent, and he had a patent, and he was able to license this patent, and our very small family fortune came out of this. So he felt incredibly proud of the fact that he invented something that the United States Patent Office had recognized as an original invention and credentialed. What he didn't like about it was that he hated lawyers. It took forever. It was incredibly expensive, and he seemed like it was a kind of a bureaucratic paperwork process that he had to go through to get his invention into the marketplace. It was the only way. It was all that could be done. So you couldn't get a product into manufacturing without patenting it back in those days. This is the way it came out, as the Moody Rainmaster. As you can see, so you could go to the beach while your garden would water itself, and it was great. It was many of you have one today. I can see our Replicator 2 here is going. I'll explain a little bit more what this is and what it's doing in a minute, but in the meantime, enjoy the light show. I spent my summers with Grandpa in the late 1970s, and this is me at probably about 5, learning how to do mechanical drawing and inventing things, taking ideas from your head and putting them on paper. And this is me at probably about 12, learning how to do machining using a metal lathe. And I remember this summer really well. I would go every summer to spend time with Grandpa and work in his workshop. But this summer, he said, we're going to make an engine. We're going to make a gas engine. I've ordered a kit. And I arrived, and there was a box, and I opened it up, and I knew what kits looked like. I built model airplanes, and it was like there'd be plastic parts on trees, and there'd be numbers and glue and instructions, and there was none of that. Inside the box were for these 4 blocks of metal and a blueprint. And I'm like, Grandpa, where's the engine? And he said, it's in there. We're going to get it out. And then that summer, we took those blocks of metal, and like a sculptor cuts away the bits of marble that aren't the figure, Grandpa cut away the bits of metal that weren't the piston and the crankshaft and the cylinder and all the valves, and it was a beautiful thing to see, and the curlicues of metal piled up around our feet. And I could see that in the hands of a great craftsman, anything could be made. And then I forgot about it for about 30 years. I didn't go back to his workshop. I remember it was the last scene before I left that last summer. We went to visit the factory. Went to where they made the sprinkler system. And we showed up, and it was clear they had no idea who he was. Eventually, they found somebody who'd been there for a long time, and they explained that this was Mr. Hauser, who had invented the sprinkler system that they were now making. And they said, oh, yes, of course, it's a great honor to meet you, Mr. Hauser. Let me show you the plants. And they showed him the factory line, and he was clearly lost. He'd never seen it before. He didn't really understand. He'd lost control of his invention. And I remember being embarrassed. And I remember driving back, and he was an old man and drove kind of slowly on the highway. And I felt just mortified. And I wasn't proud of my grandfather. I feel terrible about this today, but I wasn't proud of my grandfather. And I didn't know why, but it was just somehow that he'd lost the plot. That although he'd invented something, he didn't take it to market. He didn't build a company. He was an inventor, but he was not an entrepreneur. And the world passed him by. It wasn't enough to make something. You needed to put it into production. You needed to reach market. You needed to maintain control throughout the process so that you could really understand its impact on the world and build a company around it. And he didn't do that. What he did was patented and licensed, and then somebody else built a company around it. And as a result, he never left his workshop. And my last memories of him were a little old man tinkering, with his tools, and while the modern world went off and did something else. And that's why I didn't follow his path. I also didn't follow his path because I wasn't a machinist. I didn't have those skills. And although I might have ideas, I had no way to put them into practice because I didn't really know how to use a metal lathe. In this picture right here, 10 minutes after this picture was taken, Grandpa measured the piston that I was cutting and realized that I'd mismeasured it with the micrometer and that we had to start over again. And I realized that machining was hard. And I didn't have those skills. And you needed those skills to take an idea and make a prototype. And you needed a prototype to make a company and to do everything else. And it was too hard. And so I didn't do it. And so I, like the rest of my generation, went to screens. And we became the digital, it was computers. And it was software. And it was bits. And we lost And we lost track of atoms for a long time until something reawoken that spirit. And I realized that atoms had gotten cool again. There's a movie that came out a while back called Flash of Genius about the invention of the intermittent windshield wiper. It's a fictionalized version of it, but there's a scene that reminds me a lot of my grandfather and me. This is a scene in the basement, a man and his sons, and there's a prototype of the intermittent windshield wiper. That's the one that pauses when it's not raining very hard. He's got a little sort of motor and timer circuit, a little delay circuit. And what he's doing right here is about to make a horrible mistake. Because in this movie, he does something my grandfather did not do. Yes, he patents, but rather than license to Ford or GM, he decides to start his own company and build his own factory. And 61, and he mortgages his house, 61, 62, 63. It takes forever to build a factory. Production lines, forklifts, people, machines, and years go by. And in the movie, it's 1964, he's in Detroit. His factory's still not finished. And he leaves the factory in the rain and turns the corner, and the new 1965 Mustangs are being driven by to be unveiled for the first time in the rain, and their windshield wipers are pausing. And he realizes that his idea has been stolen, he's ruined, and the movie then tracks his descent into madness, and it's all very entertaining. And in the end, he sues Ford for like $10 million, so it works out okay. But the lesson there was, don't be that guy, right? Don't dare become an inventor who wants to become an entrepreneur. Do not dare to go into manufacturing because it's too hard, because the big guys will crush you, because you have to build a factory, because it will take years and 3 mortgages, and you will go insane. And that was the lesson of this movie, and that was the lesson of the 20th century, and that's why my grandfather never left his workshop. And that was then. And this is now. This is a picture from Tech Shop. And Tech Shop is one of a series of maker spaces around the country. And what this is a gym for manufacturing, a gym for making things. In the same way that a gym is a place where for a monthly subscription fee you have access to tools you couldn't afford otherwise or wouldn't want in your house. You have access to training. You have access to other people doing the same thing for inspiration. This is the same thing for manufacturing. Here at a Tech Shop, you'll find, shop bots from our North Carolina friend Ted Hall. You'll find 3D printers like this one, CNCs of all sorts, machining tools, laser cutters, the works. And it's full of people making extraordinary things. The guy here in the front is doing a wireless control module for the smart grid, electric grid. Guy behind him is doing a vapor deposition chamber for synthetic diamonds. And in the back, underneath that American flag, they're making a lunar lander because why not? And this is the seeds of something new. So what's interesting about, for example, that guy in the front with the wireless control module, at the end, what he's doing is he's hand assembling the last bit of a small batch of these things. And at the end, he puts a little sticker that says ABB on them. And ABB is the big, I think, Swedish engineering conglomerate. And at the end, it'll be sold by ABB to their customers for a high value price. And no one knows that it's made by a maker in a tech shop because they don't have to. Because it doesn't matter, because this guy has access to world-class making tools, world-class manufacturing tools. And if he wants to do a bigger batch, he doesn't have to do it here in Tech Shop. He can just upload his files to various services to have made for him at any level. And so what you have here is the beginnings of a digital-driven manufacturing process that looks a lot like the web. So what we have is, in the same way that the personal computer and the web and 3D and 2D printers allowed us to have professional tools at our desktop, 3D printers like this and CNC machines and laser cutters and 3D scanners and cheap CAD tools allow us to have the tools and manufacturing available cheaply at our desktop. And what that does is something super important. Technology revolutions are not about technology. They're about who uses the technology. The most powerful force in the world is the force of democratization, the force of taking things and giving them to everybody. And what's happening with digital manufacturing is not new. As you know, it's been around for 20, 30 years. What's new is that we've introduced the words desktop and personal. It's now democratized. And the pool of people who can and are doing it has grown thousandfold. And that explosion of creativity and innovation and ideas and applications and energy is what's driving this new industrial revolution. And places like Tech Shop are where you can see it. This is a a map of all the maker spaces in the world. And there's some here in North Carolina, there's some everywhere. And they're growing very quickly because they tap into a transcendental human need, which is to make things and to make things together. And the tools are now affordable enough that you can have one. Remember, with a photocopier, where'd you get your first photocopiers? The public library. Then it was the schools. Then it was Kinko's. It's not by coincidence that the CEO or the chief operating officer of Tech Shop came from Kinko's, where you're getting this moment where you can start to imagine these maker spaces in every town, maybe on every street corner, maybe in libraries, and certainly in schools. That's a return to the shop class that we lost in the 1980s, but it's a return under a new guise. This is the digital one. What's driving this is not maybe someday you can work in an auto parts, but not on an auto repair place. It's that digital design is something that a 21st century workforce is going to want to know. Digital design is the new PowerPoint. It's the new computer literacy. It's the kind of thing that a generation of kids who grew up with video games want to do and now can do. And this becomes the workforce of the new manufacturing age. This is basically the only words, which you actually, I hope that didn't fall off the end of the screen. This is basically the thesis. For the last 20 years, we've done an extraordinary thing in creating a new innovation model online. The web is, if nothing else, a new way to work together to do things that we couldn't do as singular, and that individuals can do things that companies couldn't do. The web is an open innovation model. We've seen it work. That was in bits. That was on screens. That was pixels. It was information. Now we have the opportunity to apply that same model to the biggest industry in the world, manufacturing, because the tools are now digital and the file formats are digital, and we now have the ability to work together online, even though we're not proximate, even though we're not in the same place, we don't even know each other. We have the ability to get this kind of collaborative, this co-creation model that works so well on the web and apply that to digital design and making physical things. Industrial revolutions are a big deal. You know this, but I just want to make clear how big a deal it is. This is the first industrial revolution, started in 1776, same year as the American Revolution, with the spinning jenny. This is a kind of foot-powered spinning machine. It looked a little bit like this, and what it did is we'd had spinning wheels for thousands of years, probably all the way back to medieval times. But what this did is it allowed one person to operate many wheels simultaneously, initially with a foot treadle. And it amplified human potential and began to replace muscle power with machine power. And then that foot treadle became a horse, and the horse became water wheel, and the water wheel became steam engine, the steam engine became electric motors, and you know how that goes. But basically it was this. It was a multiplication of human effort. And it created the cottage industry, and then the cottage industry created the small mills, and the small mills created the factories, or manufactories as they were originally called, and that created the Industrial Revolution. Now, you may think of the Industrial Revolution, the late 1700s and early 1800s, as being dark, satanic mills, right? Nasty places with terrible fumes. And the early factories were not great. But what it did to the world is kind of amazing. This is the population of England and Wales, which is basically flat until the Industrial Revolution, and then skyrocketed. The Industrial Revolution, in 100 years, the introduction of these machines doubled life expectancy. Doubled it. How did these machines double life expectancy? Well, what they did is that they ended up concentrating populations around the machines and built the industrial cities, Manchester, Birmingham, and others. And people went from the farms and the countryside to these cities. Now, originally, when they first did this, these cities were overbuilt. The roads weren't paved. They were crowded conditions, etc. But very quickly, the infrastructure of modernity was built around it. The schools, the sewage systems, the running water, the healthcare. And those buildings were started as wood, then became brick, and then they were dry, and there was roofs over the head. And then you realized that bucolic, countryside that we think of as being so fantastic didn't have sewage systems, didn't have healthcare, didn't have education systems, didn't have that concentrated infrastructure. And by simply moving people into the cities to follow the machines, the motive force of the Industrial Revolution, we ended up building what concentrated populations need, which is all these other elements that we now use to define modernity. And that's what doubled the lifespan, and that's what increased the population, is that machines forced us to build a support structure for modern cities. And modern cities, and that kind of, the healthcare and everything else that went with it, are the kind of things that doubled life expectancy. Plus, the walls were dry as opposed to the ones in the country. And this is kind of an interesting chart. This comes from Andy McAfee. But this is all of recorded human history, or not all of it, but as far back as we've got. And what's measuring here is just two things: world population and social development index, which is basically a quality of life index, including things like life expectancy. And basically, nothing happened. From a kind of a human development perspective, nothing happened until the Industrial Revolution. So, the Roman Empire, Jesus, Muhammad, the Renaissance, the Greeks, the Romans, the Egyptians, you cannot measure it in terms of these kind of fundamental qualities of the human experience, which is how many of us are there and how long are we living and what's our quality of life. And the only thing that really sort of shows up is the Industrial Revolution. So from a kind of this basic level of like how are we doing as a species in propagating in ourselves, machines, moving from muscle power to machine power was the only thing that really changed the game. And that was the first Industrial Revolution. So the second Industrial Revolution was probably the computer, but I'm not going to show you the first computer, which was in the 40s, and I'm not going to show you the mainframe or any of those early computers. I'm not even going to show you a computer at all. I'm not going to show you the PC. I'm going to show you instead, I'm picking here as an analogy the first laser printer, which was the Apple LaserWriter from 1986, if I'm not mistaken. Cost about I think $6,500 when it was released. And what that did, it was kind of, what this introduced was the notion of desktop publishing, which does not seem like a mind-blowing thing today, but it did then. And what was incredible about it is that it added the word desktop to publishing. Now remember, publishing was a factory job. It was an industrial act. It required a printing plant, which is like, blocks long and massive machines and, big workforces, and you needed to be, professional to have access to a printing plant to do publishing. And now here's the word desktop, and it meant that you could do it. And what you had is desktop publishing software, which meant that anybody could do layouts, and there was this thing called PostScript that allowed the same language that could print to your local printer could also drive these big factories, these big printing plants, and make something in any volume you wanted. And now we had a process that went from the desktop to mass production, from individual making one to making many, and that was very exciting. It gave us the opportunity to publish. Now we made some pretty ugly pages, the dog's breakfast of fonts, and you remember the first experience with desktop publishing, but we got better really quickly. Now that was only going to make a few of something, unless you were going to send it off to a printing plant. But then we democratized the tools of distribution as well with the web. And now publish is a button on your screen. And I know all of you have clicked that button. And I just want you to think for a second what you did when you clicked that button. You basically turned, an entire industry built up since Gutenberg that used to involve printing plants and professionals and months of work and skills and money, and you've turned it into a click. The publishing industry got turned into a click. And today, when you press that button, you have the ability to reach 8 billion people. That's democratization of technology. And that created the web, it disrupted the media industry, it created everything we know today online. Okay, so we democratized the tools of making a few, and then we democratized the tools of making many, and it changes the world. And that's the second industrial revolution. The third industrial revolution uses the exact same model. Rather than a laser printer, I'm showing the Replicator 2, which is now working here. This is a 3D printer. Quick show of hands. How many people here have seen a 3D printer before? Most of you. Fantastic. How many of you own a 3D printer? One. Seriously? One? Okay. Homework assignment. No one more show of hands. How many of you have children at home? All right. Quite a few of you. Last question I'm going to ask you. How many of you, when you were growing up, did your parents buy a home computer? Right. Okay, remember that home computer? Probably cost about $2,000, kind of a big investment. Parents weren't quite sure why they were getting, but it seemed essential to a 21st century education. They were good for the kids, and today that's probably why you're here. That home computer taught you something, you got excited about it, maybe you programmed, maybe you may just play video games on it, but it changed your life. So here's my homework assignment for you. For all those of you who raise your hands and said children at home, consider at their next birthday or maybe some holiday season, it's time. This is the home computer. Doesn't have to be a Replicator 2, just 3D printers right now cost between $500 and $2,500, about the same price as a home computer. They're incredibly easy to use. It looks, you open in a box, you just plug it in, it works. If you buy, and I'm not in the 3D printer business, I'm not selling this, I'm just saying I've done it. My children are growing up with a 3D printer, and I'll show you in a minute what it does. You bring home a 3D printer, and your children will learn digital design, and your children will grow up believing that anything they can imagine they can make, and your children will be the workforce, the 21st century manufacturing economy, and it's cheap and easy and it's time. Okay, sermon over. So that's the laser printer. That's the desktop publishing. Now it's desktop manufacturing. But you're only making one or two of something. This is not a manufacturing tool. This is a prototyping tool. Andy, I think we're ready. The fact that the Darth Vader head is done and I am not means that I'm running late. This is a prototyping tool, but we now have the web for manufacturing, and it's called cloud manufacturing. And what I'm showing you is just one site. It's called Alibaba. It's one among many. But that same file, and that file is at STL, which turned into G-code, and that same file that drove that 3D printer, you can upload it to these factories, and they will make it in titanium, or they will make it, they will take the inverse and CNC it, and then injection mold it, or they will make as many as you want. And we now have the web, with the web analogy. We have the ability for regular people to push a couple buttons and get the factories in China to work for them. That is, we've now completed the circle. We now have everything we need to see a web-like revolution to come to making things. So let me just sort of end with some stories about what we're doing and how my children are growing up with this. The point is that in the same way that desktop publishing meant we were all publishers now, but we might as well get good at it. And every one of you who has a Facebook page or tweets or has a blog, you're all publishers, and you've learned some of the skills of publishing. We're not all designers. My children grow up with video games, as probably many of yours, and they play Minecraft. They don't know it, but Minecraft is a CAD program. They are used to polygonal environments and navigating 3D space on a 2D surface, the screen. They're good at this stuff. And now, those CAD tools, which used to be $50,000 a seat, are free on the web with things like Tinkercad. So it's time to get good. It's the same way we got good at publishing, it's time to get good at design. This is now going to be that skill that all kids grow up with, and some of them turn into jobs. So this is, I told you my grandfather did the sprinkler system, so as I got into this with my kids, I thought, well, what would Grandpa do today? How would Grandpa have invented the sprinkler system in 2010 when I did it, not 1930. And I said, well, there's only one way to know, which is to do it. Now, I should say I don't actually have a lawn or you don't know anything about sprinkling, but Grandpa did a sprinkler, so a sprinkler it must be. So I invented Open Sprinkler, and this was just an exercise in figuring out how somebody who knew nothing could just go in and replicate the process. So I Googled around, and I found there's a couple other guys who were interested in this stuff, and here it is. We designed this in about 3 weeks. It's an Arduino-based sprinkler system that basically, I think, you can buy this, although I'm not selling it. I think this is a better sprinkler system. This one's connected to the web, and so if it's going to rain tomorrow, it's not going to sprinkle today. It's connected to your phone, so you can turn it off from work or on from work. You can get data. You can connect all the sensors you want, so you can see the temperature on your phone. You can see the temperature of the moisture of the sun, or and you can have as many sensors as you want around the farm. It's farm. That was Freudian. Around the yard. I'll tell you why that's Freudian in a second. And it's open source, and so all the design files are free, and I think somebody's making it out there, and it costs like $70, and there's no subscription fee, and it's just a better sprinkler. Now, there's lots of other sprinklers that are like this, and they're probably even better yet, but the point is, in 3 weeks, plus a little more, maybe a few more weeks to get it manufactured, we were able to come up with a better sprinkler system than the world's sprinkler makers. Now, it's not as professionally done, and perhaps it's a little hard to use, but the point is it wasn't that hard. You can, in fact, do the complicated things today online. Now, the reason I was laughing about the farm is that it turns out the first customers for Open Sprinkler are a deeply underserved irrigation population, and this is hydroponic pot growers. So they're customers too. So anyway, there it turns out that they were, the traditional sprinkler system had been ignoring this sector. Now, in the course of doing this, I had to design the enclosure, and so I downloaded. I couldn't spell CAD, and so but I figured I had to do this somehow. So I downloaded a free software. This was an early version of 123D, Autodesk 123D design, and there it is. There's my first enclosure. It turned out the walls were too thin, which I only found out once I 3D printed it. But here's the other kind of mind-blowing thing. Okay, so this is another thing which will not amaze you, but just give me a moment. When you go to your word processor and you go to the file menu and you pick print and you click on that, this kind of amazing thing happens. These bits on your screen turn into atoms on a page. And this incredibly complex process by which you have drivers and PostScript and vector files and rasterization, all this kind of happens in the background, and out comes a piece of paper with some text on it. Now, I know, okay, this doesn't seem like a big deal because we're pretty good at it, but this actually is kind of amazing what's going on in the background. It's kind of a bits to atoms conversion, and it happens automatically, and it's a one-click deal. And now the software doesn't have print, it has make. And when you go to these free CAD programs and you go up there, go to the menu and you pick make, and it walks you through 500 years of industrial experience. It walks you through, do you want to do 2D versus 3D, what your material choices are, do you want to upload it to a service and have it 3D printed in titanium or stainless steel or silver, or do you want to do it on a local machine, do you want to do it on a CNC or a 3D printer? Here's some of the cost considerations, some volumetric considerations, and is your mesh watertight, and all this really, really complicated stuff. Maybe this version didn't quite do it, but the new ones do. All this super complicated stuff that used to require professionals and engineers and money and time and who you knew, and it's now a menu item. We've turned manufacturing to a menu item. So that button that said publish? We now have a button that says make. And pretty soon we'll have a button that says manufacture. And we saw what that publish button did to the world, and just imagine when manufacturing becomes a button just like that. And we're right there now. Let me show you a couple other examples. So I mentioned my children are growing up with a 3D printer. We have an older generation MakerBot at home. My daughters are really into a video game called The Sims 3, which is kind of a virtual dollhouse, and they make beautiful homes and populating furniture. But we're really kind of sticklers about video game time, and they only get 2 hours a weekend day, and then this little Hello Kitty timer goes up, and ding, time to play in the real world, girls. And they're like, oh. I'm like, why don't you play with your real dollhouse? And like, it sucks. It's not as good. I need new furniture. Daddy, will you buy me some new furniture? Now, I know the answer is no, but you have to kind of get to know. So I'm like, well, so we go on to Amazon and we go looking for dollhouse furniture. And there's 3 fundamental problems with the dollhouse furniture industry. So you didn't think you were going to get a lecture on dollhouse structural failings today, but here you are. Number 1, it's really expensive. It's like $30 for just a few kitchen pieces. Number 2, very little choice. There's like 3 or 4 different styles and never the ones that they wanted. And number 3, and this is really kind of fundamental failings, there's no standardization on size. So it turns out the dollhouses are all in all different sizes, and the people in the dollhouses are different sizes and not the same scale as the houses themselves, and the furniture is yet another size because the people don't bend properly, and so you have. Anyway, it's really hard to get these things the right size, and you spend $30 getting something you don't want to find out that it's the wrong size, and the girls won't put it in the dollhouse. You can see this is something we've been kind of processing. However, we have a 3D printer. So I said, okay, here's how we're going to get to know. Girls, why don't you go onto Thingiverse, and why don't you see if there's any designs for dollhouse furniture that you might like? And so this is what they came up with, this beautiful chair, and this is what they printed, and then they paint it, and then they love it. And what you're seeing here is a changing relationship between children and toys and children and plastic. And when they have an idea, and they go online and they find a design, they download the design, and they drag a little slider that changes the size so it's just right for their dollhouse. That's all they did. That single act of customizing it so it's just right for them gave them a sense of ownership. And then they print it, and they watch it print just like this, and then they paint it. And now it's not a cheap toy that they bought from the stores, from the shelves of Walmart, and it's not something that was mass manufactured in China. Now it's something they made. Now all they did was drag a slider and then paint it. But because they had a part in its creation, because they changed it just for them, they now have an emotional attachment for that furniture, and it doesn't go in the dollhouse. It actually goes on the window on the windowsill, so they can see it every day. And we worry about our children's sort of disposable culture and consumer culture. I'll tell you, when children make their own dollhouse furniture and paint it, it's not disposable. It's not consumer culture. This is maker culture. And now they've got a sense that they can make better stuff than they can buy. My boys, this is by the way, this is where that design came from. That dollhouse furniture they downloaded, it was uploaded by Casey Hultgren, who is by day, she's a set designer on Broadway. You can see this is one of the sets they do. And the way they design sets on Broadway is that they build models first. They used to do it with balsa and cardboard, but now they 3D designed it and they 3D printed on a MakerBot. You can see she's got the same one I've got in the background. And then when she's done, and the set is approved, then the set makers then make the real set, and then she just takes those same set designs and uploads them to Thingiverse, where they become dollhouse furniture for my girls. Why does she do this? Why not? She's not in the dollhouse furniture business. This isn't taking away anything from her. She shares because she's the web generation, and the web generation instinctively shares. If you do something, video it. If you video it, post it. If you post it, share it. This is the natural instinct of this generation. And because she's incredibly talented, and by the way, check out her stuff. Go to Thingiverse.com, type in Pretty Small Things. You'll be blown away by what she's doing, and it's all free and all downloadable. All those of you who are buying 3D printers now, because for your kids, this is the stuff you're going to be printing out. Just check out her space station play set. Yeah, boys. So this is what's possible. This is if you're a toy company, this should fill you with terror. Because basically between a set designer who puts up designs for free on the internet and my children and all your children who have these 3D printers, they don't buy toys anymore. And they don't want toys anymore. They want to make stuff, and they want to make stuff that's just right for them, and they can do it on demand, and they can participate, and it's free. So there's that. My boys, meanwhile, do Warhammer 40K mechs and print them out. A funny story about this. This is a Warhammer 40K as a board game, and with these like plastic parts, they're quite expensive, beautifully manufactured. But my boys have limited allowance; they couldn't afford it, so they're like, "Dad, can we make it instead?" And the answer is yes. And at the end of the day, we did this, and it worked beautifully. But they also were given a set of these actual figures that they were supposed to make. Turns out there's 11 figures in the set, but only 10 bases, these little discs. And they're like, "Dad, will you buy us a box of bases?" And I'm like, "No, I'm not going to buy a box of discs. We have a 3D printer." So we did it. We designed a little disc, and we printed it. Worked great. And then I thought, well, again, like Casey put her designs online, I'm just going to share it. And so I put it on Thingiverse, and then you upload the STL file, and then it's time to title it. And I titled it Warhammer 40K Base, and then press publish. And then like 10 minutes later, the first comment comes in, "Dude, you are in so much trouble. Games Workshop, who owns the Warhammer 40K line, is going to come after you. You're going to get DMCA takedown. Dude, quick, change it before they notice." And I'm like, I think this might be kind of interesting. Let's see what happens. So I'm like waiting for the DMCA takedown, which never happens. And so finally I get bored, and so I emailed Games Workshop and say, "See what I did? Do you have a problem with this?" And I said, it's just a disc. I drew a circle. Can you possibly be claiming intellectual property rights to a circle? And they said, "What did you call it?" And I said, "I called it Warhammer." Oh, yeah, that's our trademark name. So the moment you use our name, then you're admitting that you took our intellectual property. But if you just call it a disc, then for board game figures, then no problems. And so then look what everybody else did. What everybody else did is they did the exact same thing, including this design. They did the exact same thing and put it up there, and it says disc for board game, figures, wargaming figures. And then in the description it says, "This is a disc for wargaming figures. Do not use it for Warhammer 40K. If you want it for Warhammer 40K, buy the real thing from Games Workshop," which is excellent. And the reason they type that in is so when you search Warhammer 40K, it'll come up. Right. So clearly. We have not completely resolved the intellectual property issues involved with the digital design and the internet. This is, when I talked about CAD being easy, this is Tinkercad. One of my sons is named Toby, and after he saw the movie WALL-E, he decided to make Toby, the robot, And he went to tinkercad.com, which is a free website, and he designed this. And what you're seeing there doesn't look like CAD, and yet it's a very powerful cloud-based rendering engine with a CAD, that does full CAD stuff. And when you're done, you just again press make, and off it goes to Shapeways and comes down. And what's cool about this is that he thinks this is a game. He thinks this is like Minecraft or The Sims 3, and it's fun for him. Now this is great. These are like 10-year-old boys who do CAD for fun. That's what's changed. This is when $50,000 a seat license. This was free on the web, and it looks like a game. And yet it's powerful enough to drive proper manufacturing tools. So that's really cool and different. And so I just wanted to end with this one last slide. So when this is my last sort of retro reminder. Remember 10 years ago when Apple released the iPod? Their motto was rip, mix, burn. Now we don't think anything of this in today, but when you think about it, rip. This is like take a professional product and make it your own. Bring it into your computer. Digitize it. Mix. Change it. As you would see fit. Make it, personalize it, customize it. You can change this. A product, you can make your own. And then burn, manufacture a new one by burning it onto a CD or a DVD. And so, I realize we're just ripping music and making CDs, whatever those things were. But the point is simply that it changed the music industry and destroyed much of the music industry, but created something even better and bigger. And that was music. That was bits. And now Autodesk has a slogan, which is rip, mod, make. What does that mean to rip? Well, if any of you have an iPhone or an iPad or any iOS device, and you have internet access, while you're still paying full attention, go to the App Store and download a free app called Autodesk 123D Catch. And what you will have in your phone or your iPad, as we speak here, is 3D scanning. Ripping is 3D scanning. It's reality capture. And with the camera on your phone, you go click, 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 click around any object, and what you end up getting is this. It turns that object into a 3D polygon that you can download the polygon, you can modify it, and then you can print it. You can photocopy reality for free. If you have a phone, if you have an iPad, you have a 3D printer right now, you can go around and you can take things and you go click, 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 click. You've now captured it. You can now change it. You can take a coffee cup and you can decide to put your logo on it. You can then output it in steel if that's what you want. Make it bigger, longer, change the handle. We can photocopy reality, and we can do it with our phones for free. Okay, so if you needed any more evidence that you were living in the future, well, you shouldn't. This is kind of amazing. This stuff used to be crazy hard, right? I mean, you're talking about, CAD and 3D scanning and digital fabrication. This used to be, you needed degrees to do this before, and now you can do it for free with the very instrument in your phone, in your pocket. So that's a big deal. That's what we mean about democratizing the tools of production. This is the kind of stuff that everybody can do and many will want to do, and we saw what it could do on the web. Now we're going to see what it can do in the real world. That is subject of my new book. It's why I quit my job, and I'm in the manufacturing business. This, I think, is a game changer for America, for the economy, and for North Carolina. Thank you very much.